So I'm going to introduce our speaker, Mr. Kevin Daly. He'll be the lead, or the one that will be presenting most of our sessions during this coding series. He is an educator, and he probably has a better title than that from Explora Museum, but he'll go ahead and take over.
Thank you, Anita. Yeah, so my name is Kevin. I work at Explora Science Museum, and my title is the STEM Learning Coordinator there. I just want to get a quick thumbs up or thumbs down if you happen to have an Arduino with you. Thumbs up if you do, thumbs down if you don't, or you can put in the chat yes or no, just so I can get a sense of if I can do stuff with it or not. So a lot of them are no. So I will try and demonstrate as much stuff as I can on screen for you. But if you do have one, feel free to get it out and try and use it. It's just the best way to get to know how to use these things, right? Is to do it hands-on. The Arduino is a really powerful tool. And so it's basically this. It is a microcontroller. It's essentially like a small little computer. It's an interface that can work between you giving some sort of input to it, and then it's going to give you some sort of output. So it's like a mini computer. We're going to go over today some of the basics of how to install software, how to kind of get your Arduino up and running. And we'll go over a few very simple little activities just to start out with for your Arduino. And so the first thing that you would have to do with your Arduino is to install software. Whenever you are installing software, since you're probably using school computers, make sure you have administrative access for them to be able to install it. The software for it is found on the Arduino website. And let me just put it in the chat right now, so that if you want to do it now, you can download the stuff and install it. And then whenever you get your actual Arduino, you'll be able to use it. So this is the links to get to the installation part. And I'm going to share my screen so that you guys can, I can share it with you. So there's a couple ways that we can access your Arduino. So you can do it through a Windows machine, through a Macintosh machine, and also from Linux. So if you are using like a Raspberry Pi or something like that, you'd be able to access it that way. If you have, and so those are ones that you can download an actual app that you'll have on the computer that you can use. But there's also a web version too. So here's the Arduino Web Editor, and you can code online. So if you do happen to have something like a Chromebook, which wouldn't allow you to download an executable app, you would still be able to use an Arduino by using the web editor for it. So there, it's essentially accessible by all different formats for using the Arduino. What you do is you download it for whichever device you have, whether it's a Mac or a Windows machine, and be able to use it that way. So I'm going to share my screen again. Let me just redo it, my desktop, so that I can show you the Arduino app here. So I've opened up the Arduino app, and it has a few different, it's a pretty simple interface here. And it's pretty minimal, right? It only has a few buttons at top, one over on the right here. And so these are ones that will help you to, the first one, the check mark, is to verify. So looking at your code, the coding is in C++, or kind of a version of C++. And so it means it's text-based. You're going to have to type in the different commands. You have to be careful about the syntax. But the verify button right here, this one with the check mark, is really helpful. So if you happen to have something wrong in your syntax, maybe you've missed a bracket or a semicolon or something like that, it'll let you know. It'll let you know what it's expecting to have, and so that can help you in being able to fix your code. The next thing is the upload button, and so that's for uploading the code to your Arduino. That's what that one is. The next one is for creating a new file, and the files here in Arduinos are called sketches. So just so you know some of the terminology that goes along with it, they're not called files or programs, they're called sketches. You can open a sketch that you already have saved, or you can save a sketch. So those are kind of the main buttons here for the interface. And so if you have downloaded it, you'll be able to get it, your stuff here. I'm going to show you some different activities that are based off of Sparkfun. So Sparkfun is a supplier of different materials, including things like Arduinos, and they have an inventor's kit. And I believe that that's the kit that you would get from an Ide if you request it. And they have some really great resources from Sparkfun. So right here, I believe, here we go. So this page here, and I'll put this in the chat as well. This is where you would be able to get the guidebook. So clicking on this down here, let me put it in the chat. So this is the link to the guidebook. And this is what a lot of these activities I'm going to show you are based off of. So if you come to this site, click on the download button right here, you'll be able to download the guidebook. The guidebook is very helpful it's a great resource. It really is. It gives you a lot of introductory information just about the different parts and functions on the Arduino, and also has a number of different activities. One of the things that whenever we're looking at the Arduinos, when you look at it, so here is my Sparkfun Inventors Kit project board. And so I have my Arduino, which is attached to this part of the board. And then on this side, we have a breadboard. And if you've never worked with a breadboard before, these are really nice. They allow you to be able to hook up a lot of different wires and components and try and keep it all together, and be able to manage all those wires and stuff. So it can still get confusing, but it's a lot less confusing than trying to twist wires together or use alligator clips to clip to this and that. So the breadboard is really helpful. And when we're looking at a breadboard, essentially what it is it's a plastic covering, and there are different holes that go in it. Underneath there are metal connectors to be able to connect rows and columns of the different parts on the breadboard. So on the breadboard here, you'll notice that along the sides, there's two different columns, so going vertically, going up and down here. And each one of these is connected all along the column. So from this very top one all the way down to the bottom on this column, and the second one over, those ones are connected. So if I connect the wire up here in this first column and down here in this first column, they're essentially connected to each other. So that's the same, these two columns here and these two columns on the other side work that way. In the center, they're connected horizontally. So along these different rows is where they're connected. And they're divided here along the center line. So here there are many different rows with, I believe there are, how many are there? There's 5 there. Here they're connected horizontally, and 5 here they're connected horizontally. Each one of them is connected in a different horizontal row there. And so those are really helpful in being able to connect wires. On the Arduino itself, we have a bunch of different pins, what they're called, that are going along the sides. And these are the things that we will be able to connect to external devices. So if we want to connect to a light or to a speaker or to a motor, things like that, this is where we're going to connect to them. And these different pins, they're labeled with their different functions. So some of them are pins that provide ground. Some are ones that provide 5 volts. Different ones are ones for controlling it. So when you get your board, you'll be able to look at it and see it's all labeled really nicely about which the different ones are. And so we're going to connect our Arduino to the computer just using a USB cord. And so when you do that, it provides power to the Arduino, and that allows us to communicate back and forth between the computer and the Arduino, so we can upload our code to our Arduino. And feel free, any point as we're going, feel free to ask me any questions or stop me if I'm going too fast or if you missed something. Just let me know. But we'll start out with looking at a very first activity that we can do is we'll connect this to be able to light up a light and be able to control a light and how to control it. So let me share my screen one more time here. So what we're going to do is, so this is that guide that I put in the link that you can download if you want to go to page, what is it, 17 on that, or you can look on the screen here to be able to see it. In this guide and with other activities that you might find at other places online, they'll often have wiring diagrams that'll help to show you how to hook up your components on your breadboard for your Arduino. So let me zoom in just a little bit here. So this is the Arduino, and it shows how we can hook wires to the different pins. In this case, we have something that's connected to the 13 pin right here, and we have something that's connected to the ground pin, which is right there. And so it shows you the different components that we're going to use. In this case, we're going to use an LED light. That's what this is right here. We're going to use a resistor, which you can show right here on our circuit diagram. And then we'll use some wires. So the black and the yellow are just wires that are showing where to connect our things. So what I'm going to do is I'm going to try and replicate this on my breadboard, on my physical breadboard, so that we can see how to hook up our light to our Arduino. And so in this case, one of the things that we're going to be using is an LED light. And so you guys have probably seen these LEDs before. Let me just give a little bit of more information about the LEDs in case you've never really used them much. So the design of this is such that, and one thing about certain components is that they're polarized, meaning that the electricity has to go through them in a specific direction, right? So with an incandescent light bulb, electricity can go through it either way and it still lights up. With an LED, electricity has to go a specific way through it. It goes one way through it for it to light up. If the electricity is going the other direction, nothing happens. So on this, it has a plus side and a negative side. And there are a few different ways that we can tell which side is the plus side or the negative side. What is the wires themselves? If you look at the wires on an LED light like this, you'll see that one of the wires is longer than the other. It's just a little bit longer. And the plus side of the LED is always longer than the other one. So you can tell just by the length of the wires, which is the plus and the negative. Another thing that you can tell is that usually if you feel around the bottom kind of edge of the light, so it looks like it's round all the way around, right? But it's actually flat on one side. They usually have a flat side on the edge of the plastic covering of the LED light. right? And feel that that flat side is the negative side. So that's another way that you can tell the plus or minus side of an LED. And so in our wiring diagram, if I go back to that, we're gonna put our thing, and you'll notice on the wiring diagram, it shows the flat edge here, right? And so that's the negative side. They also sometimes show it in the images that one is kind of a straight wire coming out of it, and another one has kind of bent and comes out. And so that's to show that this one is shorter and this one is longer for the length of the wire. So those are some things in noticing these wiring diagrams to let you know which direction to orient your LED bulbs. And so I'm going to put my LED onto my breadboard here. And just like that, so the different wires will just kind of slide down into those holes. And I'm going to take some other wires. These are called jumper cables. So they are wires, they have different colored plastics on them, and they all work exactly the same. The coloring on the wires doesn't make any difference with them. It's just that they have different colors so that you can kind of make it easier to keep track of which wires are going where. But they all work exactly the same. But I'm going to take a, just to fit the diagram there, I'm going to take a black one and a yellow one and connect them to my breadboard here. So the black one, you'll notice that we want it to go, I'm going to move this over on this side. We want it to connect to where the negative side of the LED is. And if I'm putting it here on my breadboard, you can see that I can put it in any of these spaces along the same one that the LED wire is in, and it'll still be connected. And that's going to connect to my number 13 pin on my board. So I'm going to put it right there on the board. And then the black one, I'm going to connect that to the, oh, actually, I forgot to do one more thing. Let me get my resistor. So I have a resistor here. And so the resistor is super important in our circuit here. So the LED can take a certain amount of current going through it. If you get too much current going through it, it is gonna burn it out. So we use a resistor to cut down the amount of current that's going through so we don't burn out our LED. And the different resistors have different values to them. And the way that you can tell a value of the resistor is by the tiny lines that are on there. So it'll have 4 different lines painted on the resistor. And each of those lines, I won't go into the details of it, but they tell you the amount of the resistor. So this one here, which has orange, brown, and then silver, is a 330 ohm resistor. And so I'm going to put that one, actually move this over. I'm going to put that here on my breadboard, just like it shows in the diagram. So it's going to go between my the positive side of my LED, and then this other side of, there we go, of my breadboard. And so again, you'll have to, usually with these, you'll have to bend the wires a little bit to get them to angle down to go into the holes. And then I'll take my black wire to go from the other side of the resistor and put it there into the into ground right there. So this is something we want to make sure that we get them all in the right places to be able to complete our circuit. So this is my circuit that I've created for my light, and it's important that you get them correct. So if I don't get them in the right places, my circuit's not going to work. Okay. So the next thing that I'd want to do is I'd want to create my code. So I'm going to put in the code for this little activity, trying to light the light up. So to do that, I'm going to go back to Just share my desktop, so I don't have to keep switching back and forth. So I'm going to go to my Arduino IDE, my app here. And this is the code that I've got here. So the code that's here is pretty simple. In here, you can put comments in. So if you have a slash and then an asterisk, this will allow you to put in some text and stuff that's not part of the code at all. So these are just comments. So if you want to, if somebody's coming into this, then they'd be able to just read this and get some information about what the code is. Some other ways to do comments is if we have a double, so we can do a slash and an asterisk, and then an asterisk slash, and anything in between those is commented. Another way to add a comment is just 2 slashes. And what that does is it just takes things after that on that line. So this one doesn't have to have something closing it afterwards. It just means that only this stuff after that is a comment. And so in this code, it does a few different things. You kind of have 2 different sections to it. This first one here, this first section here, the void setup section, is one where you add stuff to it that kind of, how can I say it, that kind of like prepares the code, gives the different kind of, like it says setup, the different parts that are needed to create parameters for the code. And then things in this loop one, this void loop part after that, those are the things that will happen over and over again in your code. So the first thing we do is we add this one that says pin mode 13 output. And so what this does is this tells us which pin that we're going to be working with, or it'll tell the Arduino what pin we're going to be working with. And it tells us if it's going to be an input or an output. So in any code, there's kind of 2 things that you need. You need some sort of input, something that you will do to your setup. So maybe it's pushing a button, maybe it's adding some sort of light to it. So that's something that goes into your Arduino. Then your Arduino, through the code, kind of processes that, and it gives an output. So it causes something to happen. So these inputs will trigger something else to happen. And the outputs are things like turning the light on or something like that. But in this case, we have our pin 13 is going to be the output. That's where we want the electricity to go through to be able to turn our light on. Now, this code is something that's fairly short, and so it's something you could just type out on your own if you wanted to. Just making sure that you get all of the brackets and things like that. But these codes are also ones that Sparkfun has provided files for, so that you could download these, just upload them to your Arduino app, and you'd be able to just use it that way. So if I go up here to, for instance, to File and Open, or no, actually, let's go to Open here. It'll bring down some different ones, different files that are loaded. And this one here is the SIK, is the Sparkfun Inventors Kit, a guide. And this first one here is the Blink code, and that's this one that I have here. So this is a way that you can kind of shortcut, not have to type this all in. And if you wanted to download those, they are available on the Sparkfun website. If you go to sparkfun.com/sickcode, then you'd be able to just download them that way. Put that in the chat here. So this is the link for that. And you'd be able to download the code here, and it'll give you all the different files that are in that guide. So let me go back to my code here. So this code here is a pretty simple one. So we're telling it that we want it to use pin 13, and that's the output for it. And what we're going to have is we're going to have a digital write for pin 13 to high, delay for 2000, and then for pin 13, we'll change it to low. So what this is doing is that in these different microcontrollers in an Arduino, it can give a digital signal. So a digital signal is either on or off. In this case, it's referred to as high or low. With the Arduino, it gives off 5 volts. It can supply 5 volts to whatever project that you're using. So high is 5 volts, low is 0 volts. And so this is telling it that we want to, pin 13, we want it to supply 5 volts and then delay for 2000. And this 2000 is milliseconds. So it's going to pause for 2 seconds. So 2000 milliseconds is the same as 2 seconds. And then it's going to turn for that pin 13, it's going to turn it to low. So make it 0 volts. And then it's going to lay for another 2 seconds, and then it's going to repeat. So it's essentially, we're going to create a flashing light, hopefully. And it's going to pause for 2 seconds in between every time that, in between it going on and off. And so what we want to do is, maybe the first thing we could do is we could verify it. We'll just check this code, make sure that, that there aren't any bugs in it. And down here at the bottom is where you'll get the messages of anything coming from it. So if I click verify, it's going to tell me it's compiling the sketch right down here. And we'll check in a second if once it's done it, and it's not giving me any errors. It's giving some information about the size of it and so on, but it's not giving me any errors. If there was something, let's say for instance here, I take out this this parenthesis there, and then I try and compile it, we'll see what it does. So it gives me an error, right? So it's showing right here on this line that something's wrong, it's highlighted. And then down below, it says what the error is. It says it's expected this parentheses before the semicolon. And so let me go ahead and put that back in, and let me verify, and then we'll see that, give it a sec, that everything's fine. So what we do then is we'd upload it. So I'm going to upload it to my Arduino. And when you do that, when you click the upload button, there's some lights on here that are going to start flashing, and that's showing that it is, I'm going to press the upload. There we go. And we can see those lights flashing. So those lights flashing were showing that it was getting a signal to it. And so now let's look at our thing here. Let's stop sharing my code. And let's look at my up here. Oh, it's not flashing. Let's see what's going on. Let's see. I've got it in ground. I've got it on 13. It's going there. That's in that one. It's going there. There we go. All right. So there we go. So I didn't check my LED. I had it backwards, and so now it's blinking back and forth, right? So it's pausing 2 seconds in between each time, and my LED is going on. You'll notice also over here on the Arduino board, it's got this blue light that's flashing. And so on many Arduinos, they have this onboard light, which is usually connected to the 13 pin. And so that will, if you're using the pin 13 and the signal is going on or off, this will flash with it. So that'll give you a chance to kind of test out if it's getting that signal in case you need to do any troubleshooting with your circuit itself. And so we can see this is a very simple circuit here. We can see a simple code that was used to modify it or to control it. And what we can do is then modify the code and see how we can change what's going on in this physical system. So in our code, if we are looking at, share my screen. If we're looking at something like this, then I can change the pause amount here. So it's pausing for 2000 milliseconds for 2 seconds. And so I can change this to make it smaller or bigger. Let's make this say 500 milliseconds. So half a second. And so this is going to be the pause between when it's on and it's turning off. I'll leave this one still as 2000. So that's going to be when it's off, turning back on. So let's go ahead and then upload this code and see how it changes our system. So now looking at the system here, you'll see that it's no longer 2 seconds and wait and 2 seconds and wait. Now it goes on and then goes off really quickly and then is off for longer, right? So this is a way that we can change how the system is reacting by changing our code here. If we wanted to change something else, like say, instead of connecting it to pin 13, I want to connect it to one of these other ones like pin 11 or 12, I can do that by changing my 13 here and here and here to, let's say, pin 11. And then I would have to move my wire to pin 11 for it to be able to get that signal, because that's where the Arduino is sending the signal to. So with this, one thing that like a challenge that you could give students is to see if they can, using this basic code that's here, this sketch that we have here, how can we modify it to be able to maybe send like a Morse code message with our lights? So in this case, I have in this loop where it just does one on and off. But if I wanted to create some Morse code, I might have to do, have it blink differently in a different pattern. So if I go to like a Morse code chart here, we can see if I wanted to do, you know, a couple letters like maybe AB, then I'd have to have it blink really quickly and then stay on for a while and then stay on for a while and then blink, 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 okay, to be able to do an A and B. And so if I were wanting to do that, I would have to add to this code. So maybe I could just copy and paste. So let me just copy this part and I'll paste underneath it. And so now in my code, it's still going to loop. Once it goes through all of these, it's going to go back to the beginning, but I could change the time in between these. So if I wanted this to be a really quick one, this on from on to off, that would be a really quick one. But then if I wanted this one to be longer, so if I wanted to have like a short long, then I would make this a longer time. Let's make that, 2000 again. And so now if I uploaded this, it would do a short one, which is this on to off. And let's make this just 1000. And we'll make this 1000. And that's when it turns it back on. So now I'd do a really quick one from when it's on to off. I would go back on, stay on for a while before it goes off, and then go back here. So if I uploaded this to my Arduino, let's let that load. There we go. Make it loaded. There we go. So now it's on for a while, it does a blink, and then a long. So now it's doing a short and a long. And so that's how we could start to build up, be able to program some sort of Morse code message into our program here. So that's a really quick little introduction, quick little activity to our Arduino and creating a circuit. I'm curious, are there any questions or comments so far for how how it works.
I was just curious. So when you're writing your own code, so if I try to write my own code or I try to write like pin mode, for instance, mine shows up black. Do I need to like go in somewhere and in like input a pin mode, or is it? Do you know what I mean? Like write
Yeah, I
code,
think so.
write pin mode.
So if you're asking about like why does this one kind of show this color change in it? Is that what you're asking about?
Yeah.
Yeah.
I mean, and I know in like MATLAB, for instance, like if something's coded correctly, it shows up the right color. So I'm wondering if I'm coding it incorrectly by just typing it in, or am I supposed to do like tab type it in and then it will turn orange, or?
It should change orange. I mean, one thing you could do is also verify it afterwards.
Oh,
Um,
I didn't click
and
that.
I think that might cause it to change the colors for it so that you'd be able to see that it that it's the right syntax and so on for it.
Okay.
And so all of these different things, I wouldn't expect anybody to memorize, all these different things. There's resources, libraries that you can look at for the different functions. But you can also pull from these different examples that like Sparkfun have, or there are some already built-in sketches in the Arduino Ide that you can use as well, that you can pull up, and it'll give you some of those different commands that you can use. So let's look at maybe trying another one. So we'll add to this a little bit. So right now we have it where it is just turning this light on and off. But let's go ahead and add to this what we have here. And let's add a potentiometer. So a potentiometer is something that is, it's essentially a dimmer switch. So what it does is it's a variable resistor. So you can change the resistance of how much electricity is going through the potentiometer. And so that can cut down on how much energy is getting through to, in this case, to our light. So we can change some things about it. So what we're going to do is we're going to create this circuit now. So it's basically just adding on to the circuit that we already have. So you'll see here that we still have this first part, it's still the same, but we're going to add our potentiometer down here, and we're going to add some more code to it, some different code to it. Now the potentiometer itself has 3 pins, 3 wires coming out of the bottom of it. And those are because the 2 different sides of it on the edges, those are ones where you want to have the voltage coming in and then the voltage coming out. And then the one in the middle is our command, it's the variable one. So what we can do is we have 5 volts going in and then it going out to ground on the other side. And then by turning the dial on here from the middle wire, we can change how much voltage is coming out. It will be somewhere in between 5 and 0, depending on how much we turn it one way or the other. It can be a variable amount anywhere between the 5 and 0 volts that are there. And so that's how we can use the potentiometer. So I'm gonna go back to my my wiring diagram here, and I'm going to add this potentiometer to it. So I'm going to put my potentiometer here. I'm going to add some wires to it. So I'm going to have, and one thing that we can do with the breadboard, which is usually very handy, is that on the edges here, the ones that go up and down in the vertical direction, what you often do is you'll make one of them be positive. So like in this case, we're using 5 volts. So one of them will be the 5 volts kind of rail here, and the other one will be a ground rail. So that way you can, if you ever want to get to 5 volts or to ground, you'll just put a wire from your breadboard to one of those columns instead of having to go back to the board itself. So if I add a wire here from 5 volts, and traditionally the power wire, the one supplying power, is red. So I'll put a red one here and I'll put it to this first column here. So that way anything along, so here's my red wire that's going to this one. So anything vertically along that first one is 5 volts. And I will put my ground to, I'm going to move this ground wire to this second rail. And I'm going to put ground from my board to the second rail. So anything on that second rail is going to be ground. And so you'll notice when it was disconnected, when I didn't have this connected, my light is no longer going off. But once I connect this, then my light is blinking again. And then my other things I have to do is connect my one side of my potentiometer to 5 volts. So I'll connect that there. The other side of my potentiometer, I'm going to connect to ground, which is right there. And the center part of my potentiometer, I am going to connect to A0, which is one of our controller pins. So there we go. So now I've got my wiring connected, just like the wiring diagram is. And so now let's look at this just a little bit. So here on the I talked a little bit about kind of a digital signal. So the on off or ones and zeros, or in our case here, it's 5 volts and 0 volts. And so any of these ones here on the Arduino board along the right side of it are digital inputs and outputs. So they can work with that, be able to send something as a 0, 1, or on or off. Over here, we have some that are analog analog inputs and outputs. And so these ones, well, actually, these are analog ins, I should say. These are ones where you can put something in. So in the computer world and electronics world, things are often digital, right? The on off, right? That's the kind of language that they talk in. But, things often in our world they aren't always digital, right? It's not just 0 volts or 5 volts. Sometimes it's, it's 3.3 or it's, 4.2. It can vary. And so we want to be able to capture that. And so that's where we'll need an analog in. It's not just telling us if it's on or off. We want to know what's the amount of voltage that we're getting. So that's why this potentiometer is connected here with the blue wire to this one at the analog in section here. And so now let's go to our Arduino IDE. And I keep saying IDE. So IDE is an integrated development environment. So you'll probably see that with Arduinos. And so basically what that means is that, there are a number of different Arduino boards that are out there. Mine that I'm using is an Arduino Uno, and I think that's the type that you would get from Ide if you got one. But there are, lots of different ones. And what they try and do is with the integrated development environment, IDE, it's a place where developers don't have to create all the code and all the support for it, and that it might be different from any other version. So this is the integrated development environment. It's the one where we can, use the C++ code in it, has the same buttons on the top and stuff. So it's kind of like the kind of scaffolding for creating your code and stuff. And so it creates an environment where different developers can use the same types of things to be able to create it. So that's just what you'll probably hear me say it sometimes, and you'll see it written IDE, and that just means integrated development environment. It just means it's a place where you can, you're able to control all sorts of different Arduinos. You just might have to add a new library to it or something else, which has some other specific code, but it has a lot of the same basic stuff for it. So here in my Arduino IDE, I'm going to open up a new sketch. I'm going to do this one. So this is the 1B, the potentiometer sketch from Sparkfun. And this one, you'll notice it's slightly different. It has some more code in it. Let me expand this just a little bit. Oh, let me scroll this down a little bit. So here it has some different code in here. So one of them is this one. So int pot position. So this one is creating an integer variable called pot position, potential position. So
sharing your code with us.
So this is where we're creating something. You often want to create your variables of something that can change as you're going through whatever your project is. So this is a number that's, this is going to be what we're kind of recording for the potentiometer, the value of what it is coming out of it. We have here serial begin 9600. So this is creating a serial connection to the computer. And we'll get to that in a minute, what that means. We're looking at the pin mode. So we're going to be using pin 13, and we want it to be an output. And then in the code here, we want to read what the position of the potentiometer is.
We can't see your code.
Oh, you're not able to see it? Oh, sorry about that. Let me reshare my screen here. There we go. Are you able to see that one now? This one, the potentiometer one. Sorry about that. So again, here's the integer of the potentiometer position. Pin mode 13, we want it to be in the output. And then here we're looking at the position of it. We want to read what that value is. And then this is going to print that position. But then we want to change the speed of the blinking. So I have it here that we're going to write whatever that, we're going to write this is the same as before. So for 13, it's going to turn on the light. That's what this one is. So write 13 high. So that turns it on. But then for the delay, notice instead of a set number here, like I had, 2000 before or 500, now it's whatever the potential, the pot position is. So what that value for the potentiometer is. And then again, for this delay, it's also that. So we can change how quickly it's flashing or blinking by twisting the potentiometer. So by changing that value, we're going to see the blink rate change on it. So let me upload this to my here. And so we see it's blinking. Oops, hold on. There we go. Now it's downloading. So this is blinking, shows downloading. There we go. So it's blinking. All right. So now we can see it's blinking. As I turn the potentiometer here, this little dial, we can see that it can get faster, or we turn it the other way, it can get slower. And so this is one where we have something that's variable. In this case, the amount of current that's coming out of our potentiometer, and we can see that we can change the blink rate, essentially changing that delay in between when it goes on and off by doing that. And so that value is something that we can actually look at in the Arduino IDE. So here in the Arduino IDE, if you look on the top right of it, there's the serial monitor. So I'm going to click on that. What that does is it brings up this, which is showing the value of that variable, of because that's the one that I said in here to print. Move this down just a little bit, right? So this one that says serial print pop position, that's what it's printing. That's what the value is. So as I turn the dial on this, that number is going to change. So it's getting smaller and smaller. So here it's at, almost 100. And so that means there's just 100 milliseconds, so a tenth of a second in between when it turns on and off. If I turn it up some, let's turn it up. Once it gets up to almost 1,000 now, right? So at 1,000 milliseconds is 1 second. So now there's almost 1 second in between when it turns on and turns off. And so we can look at that actual value there in our serial monitor. So that's another thing that we can see. And so that serial monitor is something that can be really useful for other projects as well. Let's say that we're wanting to, so you want to know the value of something. Maybe you're looking at a temperature sensor that you're using. You'd be able to have a readout of what that actual number is from your temperature sensor. Or if you have a light sensor, you could have a number readout of how bright or how dark it is that sensor is registering. All right, before I move on, any questions or comments about that?
What kind of board should be used in the Arduino? Because I can't see Arduino Ide in my options.
So you've downloaded the Arduino IDE. So
I'm
you
using the online one.
Oh, okay. So if you're using the online one and you have your Arduino plugged in to the computer?
Yeah.
Okay. So for the online one, let me just quickly show you guys the online thing as well. So let me bring that up. So the online version works pretty much the same, but so here is my online version of the Arduino editor. And so there's a couple of things that you would need to do for this. One is that in this section right here, you're going to need to connect your board and your port. So it needs to know what type of board you're using. So if it's Arduino Uno, which if you got it from Anita, it's an Arduino Uno. So for that, you would, let me see. So if you click on this dialog, this drop-down box, it'll say select other board and port. And it'll give you options for the different boards that you can use. And it's alphabetical. So I would scroll down towards the bottom to Arduino Uno. I'd click on that one. And the port, it'll have, I guess I just have one port that's available to me right now. But once you plug it in, you should be able to see it's a serial port that you're using. It may give you an option of like a Bluetooth port or something like that. If some Arduinos, if you have a Bluetooth connection to it, then you'd be able to connect it that way. But you want to connect your board and your port and click OK, and then it'll allow you to connect to it. Oh, and actually mine just disconnected from it right now. So that's how you would go for that. And same thing, you can import files. So if I had those circuit or the Sparkfun Inventors Kit codes, I could, and I've imported them here, so you can see them and you'd be able to connect to those different sketches. Ariel, were you able to see your connect to the correct Arduino there?
Yes. Thank you about
Okay,
that.
great. You're welcome. All right, so
Can I
let's go on. Yeah, sorry, go ahead.
You can't SSH into an Arduino, can you?
I'm not sure, to be honest. You
'Cause
might be able, there might be some workaround for that. I would have to look that up, but you
Yeah.
probably could, there's probably some connection, some
It says you gotta
settings that you
use
can-
a Raspberry Pi
Okay.
to get around it. Yeah, because, well, I can't talk to my Arduino. All I have a little Arduino Uno that
Mhm.
came with no cords. And I found all I have are, I have these. And this, I've got, this one is all I have is a power cord to this one.
Yeah.
And then
And the other
that-
one's an old, a different type of connector. Yeah.
Yeah.
That you might just need to, find, look for.
How do you
find a
connect to
cord.
the Unos?
So there are, USB to, I don't know what that, that one is called.
RJ45 or something.
Yeah. So you'd probably have to,
An
like
adapter.
order an adapter. Yeah. So
Oh.
I'm sure they have USB to that type. You just have to probably
Mhm.
look it up online or something like that to order one.
Okay. You don't have an Uno?
I do. It's a well, I have a Breadboard, which
okay.
is an Uno. Essentially, it's just branded as a Breadboard. It's still an Uno, but it has a USB. Oh, I can't remember which one it is. It's like a B or something like that on this side that connects it.
Okay, so Anita might have adapters.
And so just adding, there was a chat that I was going to respond privately, but I guess it's important information to everybody. So, for the competition or for anything that we're using, it doesn't really specify which Arduino you have to use. So whatever you may have on hand, they're all similar-ish. And so if you get whatever version you have to work, by attending a workshop, you do get your choice of microcontroller kit. So if we'll send you a full set of whichever you choose by attending one of these workshops after attending today. So you'll have a full set that'll come with adapter and everything else if you want to stick with the Arduino. The question that I was referring to is if any of you guys did any of the bots with Dr. O'Malley, the battle bots, those Arduinos will also work fine. Those Arduino, and I don't think they were the Unos, but they were a different board, but those boards will also work. So just kind of keeping that in mind that when you complete your survey, you'll be able to let me know which microcontroller kit you would like to send you, and we'll send a complete set of stuff after this week.
Okay, thanks.
Yeah, and if you do get the Arduino kit, so I believe it's the same one. The Sparkfun Inventors Kit is the one that you'd be getting, and they come with a lot of great stuff. So let me just show you what it is that they come with. So it has, go up to the top here. It comes with all these different components. So it'll have the board itself. It'll have a breadboard. It's got some gear motors, servo motors, some jumper wires, resistors, photoresistor, temperature sensor, push buttons, LEDs, a buzzer, a distance sensor, LCD display. So all these different things. So it comes out with a lot of different components that you can use with your Arduino. And so it's got a lot of versatility to it. So that was really nice. Let's move on so I can show you just another component that we can use. Let me get down to it. It is, no, past that. So let's look at sound, or let's listen to sound, I guess. But let's see about adding sound to our Arduino and how we can do that. What are some ways that we can use sound? So one of the things that the thing that we'll use for the sound is this little piezoelectric speaker. So it's a small cylinder, black cylinder, has two wires coming out of the bottom. And you can kind of see here on the wiring diagram kind of what it looks like. For these, it also is polarized. So it means that electricity has to go through it in one direction to be able to get it to work. And the way that you can tell which side is plus or minus, if you look on the bottom of it, and it kind of shows it here down below, right? It'll have a plus or a minus sign. It's either the one I have, it's in kind of a copperish color. This one on the screen, it shows it as kind of a lighter green. But also it'll have it up above a plus marked on it. On the screen here, it shows it as on the side. On the one that I have in my hand, it has it on the top, and it's in black still. It's just kind of etched into the black casing that you can see it, but you can tell which side is positive by that on top. But I'm gonna wire this one together just like it has it on the screen. And so for this, let me take out my other stuff from my previous one. And still going to use the potentiometer on it, but notice we're not going to use all three parts to it, right? We don't need to really have all three pins of it from it. So I'm going to wire my, from my potentiometer, one side is going to go to ground. So I've got one side going to ground. One side going to ground. I've got my central part of it going to the negative side of my speaker. And from the positive side of my speaker, I have it going to what is it? It's going to pin 10. Okay. Pin 10. There we go. So there. So it's a simple wiring for this one. It's very straightforward. And now I'm going to load my go back to my Arduino Ide. I'm going to load. Are you guys able to see my Arduino Ide here? Yeah. Okay. So I'm going to open from here. I'm going to go to buzzer. There we go. And so here's the code for my buzzer. And this one is kind of interesting. So with this, we're going to, so looking at the code here, we want to, in this case, create our variable, in this case, speaker pin, and we're setting it to pin 10. Okay, so that's where we want the buzzer to be connected to. And for that pin 10, we're making an output. And now here in my loop part of my code, I'm saying we're going to play some different notes here. And each of these different ones, you can see it's got two sections to it. It's got the note itself, and then how long we want that note to play for. So that's what these ones are, the different letters of the tones, and these numbers are the length that tone is going to play for. And down underneath there, these different tones, like, you know, E, F, C, and G, and so on, we're going to create an array. So an array is a way that we can assign values to these different variables, these different things. So we're going to give, here's the first part of my array, which gives the C, D, E, F, G, A, B, C, and so on. And then the second part of the array is giving us the frequency for each of those notes. And so these are the frequencies for those different notes. So like the, C is 131 for the frequency. And so this allows us, instead of having to write each one of these frequency numbers in our code, we've got it so that we've replaced it with these letters, so that it just makes it a little bit easier for us to change things in our code. We can just change the the letter for our notes instead of trying to find the specific frequency. And then down here it just has commented in what those frequencies and the notes are. So with this, I'm going to go ahead and upload this file, or upload this this sketch to my Arduino. And there we go, it's downloading right now. So when that, oops, and is able to hear that? And so this one, you'll notice that it's in the loop, but we say it's just going to go through once. If we want it to play again, what we can do is we can reset it. So they'll go back to the beginning of that. So the reset button on your Arduino is right here next to where the power cord. There's a small button right next to where the power, or where to the USB cord plugs in. And by pressing that, it would restart our code, and so it would start playing again. And one thing to notice also is that in our code is, where is it? Is that we can change the volume by changing our potentiometer. So I'm going to turn it up and turn it down. And that allows us to be able to control the volume for our song here. And so that gives us another little thing that we can do for adding to our repertoire of components that we can use with our Arduino, is using the sound, using that speaker on it. So any questions so far about this, or any other things that we've gone over?
Kevin, before you end the session, I know you talked a little bit about the web, or the web portal. If maybe for some of our newer teachers, we can go over maybe the pros and cons of each, because that is available, but
Sure.
I know for most things that prefer the downloaded version. So what the drawbacks are to both, and if you could actually put maybe the link to that in the chat, just so it's captured in the chat log, that would be helpful.
Sure. Great. Yeah, of course. So let's see. So pros and cons, and let me just put this in the chat first before I start talking. So one thing is with the web version, one thing that you would have to do is you'd have to create a login for yourself. So you would have to have an account with Arduino. It's free, it's no problem like that, but you would have to have an account that you would be able to log onto, so that you could, the link to that, to be able to access that. So you'd so if students are if you have students doing it, they would have to have a login, and have to remember what their login is. I think you can log in with Google, or a couple other ones, probably Microsoft or Apple. I don't remember exactly, but you'd have to have a login for it. If you have the downloaded version, you don't have to worry about logging in, right? It's just an app on the computer. I find that sometimes connecting to your Arduino through the web, the web editor, it kind of, I wouldn't say it's hit or miss, but it's kind of finicky sometimes to get it to connect. I find that through the app, it connects really kind of seamlessly once you've gotten it set up. So that's something to be aware of. But for some things, you can only use the web editor for it. So for instance, if you have Chromebooks, there isn't an app for that, you'd have to use the web editor for that. So I hope that answers that question. But both of them have the same capabilities, right? You can still do all the same stuff with both of them. You can upload or save files to it. So it has the same capabilities. I just find that the app is seems to be a little more seamless in connecting to the Arduino. All right, we've got about 15 more minutes left. So maybe I'll go over one more thing that we could do, quick little activity with our Arduino. And for that, let me pull it up here. Let's look at controlling a servo. So controlling a motor of some sort. Okay. All right. So a servo, I've got one here. A servo is a specific type of motor. So if you have just a regular hobby motor, like this, you'll notice that, you know, it's got the two wires to it, right? It's got a red and a black. So you just put electricity into it, and once there's electricity, it starts spinning and it just keeps going. So that's just a regular hobby motor. A servo works slightly differently because it has three wires. In this case, on this one, it's got a red, black, and a white one. And so this servo is one that you can, it still needs power, right? So it still has the red and the black wires, which will be your negative and positive for electricity. But then the white wire is the controller wire. And so that allows you to send a signal to it or get a signal from it that will, or send a signal to it that'll help you control it. And so there's kind of, this servo is one that's called a positional servo. And so that is one that you can turn the motor, and most of them will go from 0 all the way to 180 degrees. That's the range of it. And you can tell it to go to a specific angle. And so that's one of the benefits of the servo. And so what we're going to do is we're going to connect it up, and I'll also connect up the potentiometer so that we can turn the potentiometer, which gives a, just like we saw with earlier when we were looking at the light, right? It gives an amount. It can send in an input from the potentiometer, and we'll use that to control this one. So we'll turn the potentiometer, and it'll turn, in turn, it will make this servo rotate. So to do that, let me go to my wiring diagram here. And so we'll try and hook this up really quickly. So again, we're going to use a red and a black wire to give us the 5 volts and ground to our to these edges here on our breadboard. So let me put the red on 5 volts. We'll put the black on ground. There we go. And so I still have my wires here. I'll take out my speaker. So I'll take a red wire from 5 volts and send it to one side of my potentiometer. There. I'll do black from the other side of the potentiometer to ground. I'll take the center from my potentiometer and then put it on my A0. So that's the analog input. And then for my servo here, I'm going to take a white wire, which is going to go to, in this case, it has it going to 9. So we'll go to the 9 pin, and then we'll send a red and black wire to 5 volts and ground. And so this will allow us, got a green wire. I'll use a green wire for ground here. And this should allow us to be able to control our servo, okay? So I've got it all connected, and now I'm gonna add my code. So I'm gonna open up my code for the servo. And so the servo is one in which we're going to have to add another library. So libraries are, so you could type in all this different code to be able to control the servo. But what you can do is add a library. A library is is something that will add more functionality to your project that kind of has code already built into it that's kind of distilled down to something a little bit simpler. So in this case, the way to do that is with this hashtag include servo.h. So that includes the servo library. And in the servo library, it allows me to use some of these servo commands. So this one here, so servo, my servo, that's creating an object called my servo that is the servo from the library. And then I can use this one, my servo, which is attach 9. So that's showing that it's plugged into pin 9. And I'm going to make it so that the position of the potentiometer, we're going to read that, and we're going to map it so that it's mapped onto the position of the servo. And so we're going to see if we can get it to move our servo around. So let me go ahead and download this, or upload this rather, to my Arduino. And there we go. So now if I turn my potentiometer here, I'm going to start to turn the potentiometer with this hand, and you'll see that the servo is turning when I do that. So anytime that I move the servo to one side of the potentiometer one side or the other, it's moving the servo correspondingly. One thing to be aware of with these servos is that if you go all the way out to the 0 degrees or all the way to the extremities to 0 or to 180 degrees, sometimes it you'll notice that the servo kind of like jiggles or wiggles on it. So you want to just avoid those extremes. It just kind of stresses the motor on it at the very extremes of it. So you want to keep your angles to like 5 or 10 degrees off of those extremes. But that is how we would be able to, one way to be able to control the servo by controlling the potentiometer. So I went over a number of different projects, and I know for most of you don't have your Arduino in front of you. It might not mean as much to you. If you're able to do it yourself, you can learn a lot more and be able to control some things with it. But any questions or comments about the Arduino in general, or any of the things that we went over today?
Kevin, just for the recording and just so when they reference this later, I know sometimes when connecting, like you've downloaded the software and you have your Arduino, and then the connection part, like it may be just even walking through maybe some possible troubleshooting or like how that process works. I know yours is already connected, but.
Yeah, sure. So so there's a couple things whenever you are installing your software and trying to connect your Arduino for the first time. One of those things is make sure you know what kind of Arduino you have. There is a long list of different kind of versions or makers of Arduinos, and each one is slightly different. The commands for it are essentially the same, but the interface might be slightly different. And so that means that whenever you are trying to connect it for the first time, you need to be able to tell the computer which one it is. And so to do that, hold on. Let me share my screen here. To do that, you're going to have to, in the Arduino IDE, if you go up to, I believe it's tools. Yeah, so in the tools section here, and when you first connect it, it'll ask you this, but up here, it wants to know what type of board you have. And so most of you will probably be getting or already have an Arduino Uno. If it's something different, you'll probably be able to know. But as you can see, there's a number of different types of boards that you can have. And then the next thing that you're going to want to do is be able to tell it what port that it's connected to. And so that's the next menu here. And so this is where when you plug it in, it should show up as here in a serial port. So if you're not sure which one it is, go for one that says the serial port. So, you know, Bluetooth is pretty obvious. BLTH is Bluetooth as well. So if there are any problems with it recognizing it, with the Arduino IDE recognizing the ports on your computer, this is where the troubleshooting comes into play. And the best way to do that is by going to the Arduino website. And so here, I have come to the Arduino. Actually, let me go to a different section here to show how to get that. Hold on. Let's go. Yeah, so if you go to our Arduino, the hardware one. So if you get started here, just the Arduino.cc website, you'll be able to get started with a different Arduino board, Arduino Uno, version 3, and it'll get you to a place where it'll take you through kind of steps on how to connect to it. So if we're connecting with the Arduino Ide 1.8, that's the current version. The Arduino Ide 2.0 isn't quite out yet. Do next, and it'll have you go through installing your information about your board and stuff, and then selecting the port and all that. So going to docs.arduino.cc is probably the best place to get started for doing the troubleshooting for your Arduino. And I'm going to put this in the chat if anybody needs to use that. So that's the basics of installing the software, connecting your hardware to it, to be able to get it. One thing is, once it's connected, you can try and just download one of those, any of those sketches to it. That way you'll be able to see it. So one thing I would suggest is, if you download that first sketch, so the one with the simple blinking light, that'll let you know if it's connecting to it or not, because I had showed you that on the Arduino board itself, it has that light on it that's connected to port 13, and that first sketch makes port 13 blink, and so it'll have this light go blinking, and so that'll give you a kind of a test to see if you're able to download or upload your sketch to your Arduino.
Well, thank you so much, Kevin. A little note on the attendance survey, which maybe I should have put on the chat, is when you're putting your address, it's also for check purposes. So this is your address, not your school address, because we've had very problems with that, but it's also a physical address that can accept packages, because this is also the address where I'm going to send your microcontroller. So we did have some problems last year mailing things to addresses that were incomplete, or like specifically school addresses that were kind of vague. And so please make sure and put an address that can receive a box and that can receive a check. That's what the address is for in the survey form. So before we do close out this session, I am going to quickly show you our Mesa page just for a very quick second. And this is where all of you registered for this event. So if you go to events or professional development, as a note, once the session is done, it's like what to do after the fact. All of our recordings for our 2021-22 school year, we switched over to putting everything up on our YouTube channel, but anything previous was, stored like in a Dropbox or different other formats or whatnot. But they could be helpful. So today's session will be put on our YouTube. So if you want to share this with your students, please do. Please also use this as needed when you're actually installing your Arduino. As part 2, we're going to come in ready to rock and roll. So the part 2 will start. You should have already installed your Arduino, installed your libraries, whatever you may need, and have gotten at least to the point of the basic activities that Kevin reviewed today, at least to that point. So besides today's session, there's this 2021, it's like an archived material here. I also have it in a couple of spots. I also have it here. It's basically just a PDF, which is lots of recordings of all the different trainings that we offered last year. So just, different perspectives. We have a second trainer that'll be popping in, and also just if you need to hear it again, if you need to hear the maybe beginner information again. By the time we did like our Arduino part 1s, I think we actually had the Arduino piece, so walking through a little bit more of those parts. These technical support sessions, last year we held sessions that were intended for our students to come on and get help, and they weren't super well attended, but we just turned those into like little activity tutorial sessions to where Kevin and Anthony walked through different just activities. So I recorded them, for use if that's something you want to practice maybe with your students or direct them to an activity. They're here. The recordings actually are here. So just keep in mind that those resources are there for you once you get your item. The mail out of microcontroller kit will happen. There's a session today, there's a session tomorrow on Circuit Playground Express /microbit, because they're similar stuff. And then I'll send out stuff next week. Okay, so with that, I will end the session recording here.